Every AI agent works on a simple trust assumption. When the system sees a tool call, a command to run code, read a file, hit an API, it assumes that call came from the model, that the AI decided to do it. Researchers just showed that on several major agent frameworks, you can forge that tool call yourself. You put a block of text shaped like a model's tool call into your own message, and the runtime runs it without ever asking the model. No jailbreak. No clever prompt to persuade the AI. You don't break the model's rules. You just skip the model entirely. And AWS, Google, and Vercel all shipped patches for the same class of flaw. The researchers Hedi, Ingber, and Aviyam Ivgi presented this at Black Hat USA 2026 and named the pattern CoreBreak. And the name points at the real issue. It's a break in the core assumption of how agents work. To see why that break is dangerous, you have to understand what a normal tool call actually looks like under the hood, because the whole attack is about one missing check in that sequence. Here's the normal flow. The agent's software development kit sends the model everything it needs. Your request, the system prompt, the conversation history, and the list of tools it's allowed to use. The model thinks, and if it wants to use a tool, it returns a structured instruction, the tool's name and its arguments. Then the SDK takes that instruction and executes it. That's the loop. The key point is that the tool call is supposed to be the model's decision, produced by the model coming out of the model. Everything downstream trusts it because it's supposed to have come from upstream. And here's the flaw. Between the model returning a tool call and the runtime executing it, the vulnerable frameworks never verified where that tool call actually came from. The runtime just received something shaped like a model-generated tool call and treated it as authoritative. It didn't ask, did the model really produce this on this turn? It just saw the right shape and ran it. So an attacker doesn't need to persuade the model to break its rules, the classic jailbreak. They reach the execution path without a legitimate model turn at all. The forgery works because nothing was checking for authenticity in the first place. Make it concrete with the AWS case, which got the headline CVE. In Amazon Bedrock's Agent Core, there's an API called Invoke Harness. An authenticated user could place a tool use content block into the final message of their request, the message that's supposed to be user input. The event loop would then read that block and dispatch the name tool directly without asking the model. That's CVE 2026-18830, rated 8.6, high severity. AWS fixed it before the disclosure by adding server-side validation that rejects any caller-supplied tool use block before it reaches the event loop. The fix was automatic, no customer action needed. But there's a catch on the open source side. Agent Core is built on an open source project called Strands, and the managed fix does not cover the same model skipping path in that upstream code. In the current Strands event loop, there's a check called has tool use in latest message. When it passes, the loop sets the stop reason to tool use, takes whatever's in the latest message, and skips calling the model. There's literally a comment above it that reads, skip model invocation if the latest message contains tool use. The Hacker News confirmed that branch was still present in the main branch as of August 5th. So the pattern the AWS patch closes on the managed service is still sitting in the open source foundation it's built on. This wasn't just AWS. The same class of provenance skipping flaw showed up across 3 vendors, disclosed together. Google patched it in their Agent Development Kit for Python in ADK version 2.5.0. Vercel patched it in their AI SDK harness packages for the Codex and OpenCode coding agents in specific pinned versions. Same underlying idea in 3 different agent runtimes. The runtime trusting a tool call it never proved the model produced. That cross-vendor spread is what makes this worth an agent engineer's attention. It's not one company's bug. It's a pattern in how the tooling was built. Now the honest scope, and pay attention here because it's easy to oversell. Yes, the primitive is real and a bit alarming. Forge a tool call, skip the model, and you're straight at the execution path. But read the fine print because the researchers and the reporting are careful about it. These are not identical vulnerabilities, and they don't share the same attack conditions. The AWS one needed an authenticated request. Google's needed attacker-controlled session events or user-authored function calls. Vercel's needed untrusted code already running inside a sandbox. Every path has a precondition, and the exposure is bounded by what the agent can already do. An agent wired to no sensitive tools gains an attacker nothing. All 3 vendors have patched. This isn't a breach in the wild. It's a design flaw disclosed responsibly that tells you where the trust boundary in your own agents needs to be. Here's the takeaway if you build agents. For years, the security conversation has been about the model, jailbreaks, prompt injection, getting the AI to misbehave. This flips it. CoreBreak doesn't touch the model at all. It attacks the plumbing around it, the assumption that a tool call is trustworthy just because it has the right shape. The fix isn't smarter prompts. Its provenance. Your runtime has to verify that a tool call actually came from a real model turn, not from user-controlled input wearing the right costume. Trust the origin, not the shape. If you want the full written breakdown with every CVE and source, it's on the prompt injection blog, linked below. This channel does one clear breakdown of a real AI agent attack every single day, so subscribe and hit the bell. It's the one signal that tells me to keep making these. If this was useful, subscribe. New AI agent and security breakdowns every day.